An employee receives an increment of 1000 rupees, 2000 rupees, 3000 rupees, and so on for the next few months. He decides to save this increment and make an investment after some time. At the end of 20 months, he wants to calculate how much has he saved so far and he wants to invest that amount into a house. Question: how much has he saved so far?
Okay, this problem falls into a popular category called arithmetic progression or AP as they call it. Before solving this problem, let me give you two set of numbers. One is 1, 3 and 5 and the other is 1, 3, 5 and 7. Suppose I have to find an average for this set of numbers and for this set of numbers. The average for this first set can be easily arrived by, if you move 2 here, it is 3, 3 and 3. The same thing can be arrived at by reversing the order and dividing by 2. So the average is nothing but the middle number in this. If I apply the same method here, because there are even terms in this, the average lies between these two numbers. The total for this is 9, and it can be arrived at by multiplying the average into the number of terms. So average into number of terms gives you total. Here it is 4 into number of terms, which is again 4, is equal to 16. If you add here, you will get 16. So average into number of terms is equal to total.
Please go back to concept 2 and recall that the average is derived by dividing the total by the number of innings, and therefore the total is also arrived at by multiplying the average into the number of innings. An employee receives an increment of 1000 rupees, 2000 rupees, 3000 rupees, and so on for the next few months. He decides to save this increment and make an investment after some time. At the end of 20 months, he wants to calculate how much has he saved so far and he wants to invest that amount into a house. Question: how much has he saved so far?
This person has saved 1000 rupees, 2000 rupees and so on till his savings is 20,000 rupees before he makes that investment. So the average is nothing but 1000 plus 2000, 20,000 divided by 2, which is equal to 10,500. He has saved this over a period of 20 months. So his total savings is equal to average into number of months. In this case, it is 10,500 into 20, which is equal to rupees 2,10,000.
To summarize, we have two observations that we make here. One, we can easily arrive at the average by adding the first term and the last term and dividing by 2, or even the second term and the second last term and dividing it by 2. The second observation is that when we reverse the terms and add them to the series, we make all the terms equal. Again, we can arrive at the average by taking one of those two additions and dividing it by 2.
Now, to generalize, you would have all gone through this in school, where A is the first term, N is the number of months or terms, and D is the common difference. In this problem, A is 1000, number of months is 20, and the difference is again 1000 rupees.
Please also note, in this series, the second term is a plus d, which is 1000 rupees plus 1000 rupees. Third term is a plus 2d, which is 1000 rupees plus 2 into 1000 rupees, which is 3000 rupees, and so on. The nth term, or the last term in this, which is 20 months, is a plus n minus 1 into d, which is 1000 plus 20 minus 1, 19 into 1000 rupees, which is 20,000 rupees.
So sum is equal to first term plus second term and so on to the last term. I'm writing this in the reverse order. Last term plus second last term and so on to first term. Twice the sum is equal to first term plus last term and so on. The last term plus first term. Twice the sum is equal to first term plus last term into, they are all the same, so number of months. So sum is equal to first term plus last term divided by 2 into number. The average into number, which is 1000 plus 20,000 divided by 2 into 20, which is equal to 2,10,000. So to generalize, sum is equal to first term, which is A, plus the last term, which is A plus n minus 1 into D, divided by 2, which is the average, into n. Thank you.